The question is in C 3.1 shows the sketch of sum of ionization energies of phosphorus P. And this is ionization energy he gave us here first and second, then he didn't give us third, fourth, fifth, and sixth, and seven. Okay, what the question is, construct an equation to represent the third equation or the third ionization energy. Okay, third ionization energy here, it means the phosphorus will lose how many electrons? 3 to react, so it will be P. To convert it into positive 3, it should lose how many electrons? 3 electrons to give us P positive 3 plus 3 electrons with negative charge. The next question completes a graph, okay, to show the third to 6 ionization energy of P. Okay, phosphorus, as we know, what is the configuration of phosphorus? Phosphorus, it is Ne, okay, as shortcut, then it has 3s2, then it has 3p, 3 electrons. Okay, so the first electrons or the first 3 electrons, this element will lose the first 3 ionization removed from 3b, which is the first and second and third. So the third one, we can draw it here like in general increasing or the normal increasing. But starting from 3s, or to remove the 2 electrons from s3, s2, the force remove of 3s electron, which is closer to a nucleus and more tightly bound to the nucleus, causing a significant jump in ionization energy for the fourth and fifth, and then sixth it will take the same. So to detect or to predict the ionization energy for 4, it has a kind of significant increase like that. Then fifth, it will be near from it, and this is the 6. So to draw or to complete it, we can draw it like that. So the graph, it shows this shape. So here we have between the third and fourth, we have a significant increase. Why do we have here a significant increase? Up till here we are talking about the 3b electrons, okay, the first electron, second electron, third electron. All of these 3 electrons came from 3b, but starting from the fourth electron and fifth electron, they came from 3s2. So we have here 3s2 electrons. They are more closer and more bounded, or more or strongly bound to the nucleus. So to lose 1 electron from, or to lose 1 electron from these 2 electrons which already filled and the orbital are more stable, the suborbital here is more stable. So to lose 1 electron from here, it's very, very strong bound to the nucleus, and it needs more energy, So we can find here a significant increase in the ionization energy. That's it. Still in question number 3, in point D, complete this table about the nitrogen and phosphorus, and these are the physical properties for both of them. The first one nitrogen, second is phosphorus, and the first point we should complete is the electrical conductivity. He told us here phosphorus is poor, also nitrogen is poor conductor. Type of bonding, both of them, they are non-metal, so they are covalent bonding, and here is covalent bonding. The type of structure here is simple, and the other one is simple too, as we don't have here a large or giant covalent compound. Both of them, they give me a simple compound or simple covalent compound. The second question, E, a form of a solid nitrogen has a lattice structure similar to solid iodine. What's solid iodine? Iodine is I2, so it's diatomic molecule. So if you are talking about solid nitrogen, it should be also diatomic molecule of N2, which is diatomic molecule. It has nitrogen, and nitrogen, as we know, the structure is molecular. The structure here is molecular structure. Solid nitrogen, like iodine, forms a molecular lattice with discrete N2 molecule held by weak van der Waals forces. These forces, why? Because the N2 is nonpolar compound. Nonpolar compound, it has a weak van der Waals forces, so it will give us similar to iodine N2. So here is solid nitrogen. Solid nitrogen is molecular N2, or we can write it like that, okay, and mention for weak van der Waals forces. Why? Because both of them are, or the 2 compounds, they are nonpolar compound. Van der Waals forces between them. Okay, this is the lattice arrangement for N2. At very high temperatures, phosphorus can form P2 molecule. P2 contains a triple bond, P triple bond B. Describes the formation of P triple bond B in terms of orbital overlapping. So he's asking about the kind of hybridization in case of phosphorus. As we know, it's referring to be SP hybridization, not sp2 or not sp3, as we'll see now. Okay, so how can we find, or how can we draw the sp hybridization, or how can we describe it? As we know, the phosphorus, it has the configuration of phosphorus as it has 15 electrons, so it's Ne, neon. Shortcut of hybridization of the configuration, the second is 3s, 3s, it has 2 electrons, and 3b, it has 3 electrons. Okay, this is the configuration. How can we draw it? Let me draw just the third shell, which is 3s. It has 2 electrons like that, and 3b, it has 3 orbital shells, and each one it has 1 electron, are able to react. The hybridization which can happen here is sp. It means 1 orbital from S and 1 orbital from B. They will get mixed with each other to give us this shape, which is like that. Okay, one it has lone pair of electron, and one is it needs a 2 to fill it with another 2, and still we have 2 unhybridized subshells from P. Okay, so the bond which can happen here in case of the 2 between 2 phosphorus, like, let me draw them here. This is the second phosphorus, and here this is the hybridized 2. This is sp. Okay, so this is a p1, and here this is another p. 2 phosphorus, they can react with each other. The first bond between phosphorus and phosphorus, it will be head to head. So this is a sigma bond. Sigma bond. This is the first bond. Sigma bond between the phosphorus and phosphorus. Y between the hybridized sp and sp. What about this lone pair of electron? We will find them as lone pair above the phosphorus. This is the main reason for basicity of phosphorus as in nitrogen. What about these two? These two in unhybridized subshells in P, they will make what? They will do the double bond and triple bond. So we have here 2 covalent bonds. The first one is sigma bond, second one is pi bond between this electron and this electron, and we have the third bond by this way. So the triple bond between phosphorus and phosphorus, one of them is a sigma bond, one of them is a sigma bond. That one, sigma bond, it's between phosphorus and phosphorus, the sigma bond, in hybridized subshells. And the other two, they are pi bond. That one is pi bond, and this one also is pi bond. It's between phosphorus and phosphorus, is side to side in unhybridized subshells. Why? Now the sp hybridization allows also the pp for the linear geometry required for the sigma bond in the triple bond p triple bond molecule. The 2 unhybridized sp orbitals are oriented perpendicular to the bond axis and ideal forming the 2 bonds. Do we have another hybridization in phosphorus? No, they are very rare. So in some cases, phosphorus compounds, example, PH3 or PCl3, they can make, are described with minimal or hybridization relying to 3p orbitals for bonding due to phosphorus larger size and lower electronegativity compared to nitrogen. However, in P2, the triple bonds strength and geometry favor sp hybridization more than sp2 and sp3. So higher hybridization like sp2 or sp3 are less likely for P2 as they employ different bonds, angle and number of bonds, example sp2 trigonal planar, or sp3 which is tetrahedral, which don't fit fp, which we need it as linear, we don't need it as trigonal or tetrahedral. So the summary here, p hybridization giving us linear shape, okay, linear shape. The question is, the bond energy of P triple bond B is 485 kilojoule. The bond energy of nitrogen is 944 kilojoule. Compare the reactivity of P2 and N2. Explain your answer. Okay, reactivity here, reactivity, it means the ability of each one of these two to react. So the amount of energy which we need to break down the bond, if it's more, it means this compound is less reactive. If it's less, it means this compound is more reactive. So here, as we see here, phosphorus is 485, is less than 944, which means phosphorus triple bond P or P2 is more reactive than what? Then in reactivity, more reactive than nitrogen. Why? Because it needs less amount of energy to break down this bond to let again phosphorus to react and rebuild a new compound. So as we are decreasing the amount of energy or the strength of bond, we are increasing the reactivity. Are we increasing the reactivity? So by decreasing the amount of energy which we need to break down the bond, we are increasing the reactivity. So phosphorus or P2 is more reactive than N2.